You first.
I am Astrobit. Hello.
I am Major Merger.
All right. Astronomy in the News, November 2017, our 3-year anniversary. First news before I get to it. Remember, we have keychains for sale, bottle openers at a discounted price of $2 for this month. It will be regular $3. It's for our anniversary, 1/3 off. Stop by merchandise table and pick one up. All right, on to actual news.
All right, first news story. So a new image of an aging red giant star known as W Hydrae may have revealed new clues. You guys, I think this show is cursed. I'm not kidding.
No.
Everything that could have gone wrong has gone wrong tonight.
I just needed beer.
Okay, more beer is the answer. Yes. Woo! Okay, starting over. Okay, so a new image of an aging red giant star known as W Hydrae may have revealed new clues about the fate our own sun will face in a few billion years. So located 320 light years away in the constellation Hydra, W Hydrae has the same mass as the sun, but a diameter twice the size of the Earth's orbit around the sun, as you can see in this top image here. Yeah, I heard it. Okay. So the Atacama Large Millimeter Array in Chile captured... Oh, got some Chilean fans in the house. Okay. So ALMA captured this image, which provides the clearest view yet of the surface of the red giant. Yeah, we are so hyped tonight. I like it. Okay. But once a star like our sun has burned through all its hydrogen in its core, the star begins to collapse due to the lack of outward pressure from that fusion process, and this causes the core to heat up, allowing for helium to fuse into carbon. And the energy from this fusion process causes the star to expand outward, which in turn causes the star to actually cool down and gives off the red coloring that you see. So one feature that Wouter Flemings, an astronomer at Chalmers University and lead author on this study, was not expecting to find was this bright spot here in like the southeast corner of the star. Thank you, Brian. Which is in the chromosphere of the star, and it's a lot hotter than predicted by current theoretical models. So they suggest this is due to powerful shock waves created as the star blows out its material during its expansion, or it could be a giant flare that they were just lucky enough to capture in this image. So Fleming said observations like this are exciting as they provide further insight on the future of our own sun. So yes, in just a few billion years, our own sun will expand out and engulf us all. So something to look forward to. Yes.
The ultimate global warming. All right. The first known asteroid that's from outside our own solar system has been discovered. So October 19th, asteroid OneEye 2017 U1 was discovered moving across the sky at about 6 degrees per hour. And so 6 degrees per hour, to give you some perspective, if you hold your hand out at arm's length, the width of your hand is about 6 degrees. So it was moving across the sky every hour at about 6 degrees when it was at its closest point. So the asteroid has since been named, I'm going to butcher this.
Do we have any native Hawaiians in the house to help us?
Hawaiians, anyone? Oumuamua. Oumuamua, so it's moving so fast that it probably has not come from within our own solar system. There's this Oumuamua? Oumuamua.
I don't think that's
Brian can come up afterwards and teach us. So it probably has not come from our solar system. It was not discovered until it had already passed both the sun and the Earth. It's already on its way out. It's going to take about another 10 years. There's a picture in the lower right here. Hopefully everybody can see it. And there's where the arrow is. I don't know if you guys can see it there. Can you see a little dot right by the arrow? So that's the asteroid itself. All these other dotted streaks are stars. It's moving so quickly that the stars move that much. This is a series of images tracking just the asteroid. So the object's probably moving too quickly for us to be able to send a probe to study it, and is too faint to be able to determine the composition through normal means of taking spectra, but the color is similar to that of other asteroids within our solar system. It's also cigar-shaped, kind of shown in the artist's impression here. It's about 100 meters, wrong one, about 100 meters long this way and about 30 meters wide. It came from the direction of the star Vega, but it probably did not come from the star Vega itself. My personal theory is that this is actually an alien spaceship. They learned that Trump was president and said, just keep going.
Some smart aliens. Okay. All right, so astronomers have discovered the oldest spiral galaxy ever seen, located a mere 11 billion light years from Earth. This means that we're seeing this galaxy when the universe was less than 3 billion years old. So spiral galaxies are exceptionally rare in the early universe, and Ryu Sen, an astronomer from Princeton and co-author on the paper outlining this discovery, says this opens the door to investigating how galaxies transition from highly turbulent systems to tranquil disks like our own Milky Way. So this galaxy, with another very clever name of A1689b11, was discovered using the technique of gravitational lensing, which we've heard a decent amount of here at AOT. So this is when light from the galaxy, as shown in this image here, is bent around a massive intervening galaxy cluster and thus magnified for us to see. So the observations were taken with the near-infrared integral field spectrograph on the Gemini North Telescope located on Mauna Kea in Hawaii. And with observations like this, we can really start to nail down the details of the formation and evolution of spiral galaxies in our universe.
All right, so a very unusual was reported this month by E.R. Arkavi and Andy Howell. They're shown in the lower left. You might remember Andy Howell. He is a former astronomer here at UT and also gave a talk, I think it was last December, here at Astronomy on Tap. So this massive star exploded. It was first noticed on September 22nd. Typically, massive stars, when they explode, they dim over the course of about 100 days. So there's a plot kind of in the lower right here. That here's a normal supernova explosion of this type. This particular one, however, so it started to fade, and then about 2 months later, suddenly got brighter again. So it started to fade and got brighter again, and then since then has gotten faded and brightened about 3 more times since the original explosion. There may also have been an eruption in 1954. Archival data shows that there was a brightening basically in the same spot 50, 60 years ago. This object is extremely unusual and does not fit any known models of stellar explosions. The images that you show here, that are shown here on top, here is an archival image of before the explosion, so in B, and C is the image with the explosion, and then in D is basically image C with image B subtracted from it. So all you see in image D is the supernova itself.
What happened to A?
I cut out A.
Okay. A wasn't interesting.
A wasn't interesting. Actually, I think A was the 1954 image, and I just felt it was too confusing.
Okay.
So the luminosity of this object, several billion times brighter than the sun, is too bright and too persistent to be any other known astronomical entity. So so far, we think this is sort of a normal supernova. Obviously, it's not a normal supernova, but we don't really know what's going on. Studies are ongoing as to determine how the brightness correlates with Kanye West's ego.
All right, so you guys have heard about this twice now tonight, but I made this slide before I knew what our speakers were going to talk about, so you get to hear it again.
Thanks, Charlie.
So last week was a very exciting one for all the astronomers here at UT Austin. The Space Telescope Science Institute, which manages the James Webb Space Telescope program, announced the 13 proposals selected from 106 submissions for the initial round of science observations to be done with JWST. So these 13 programs are part of the JWST Director's Discretionary Early Release Science Program and will be conducted within the first 5 months of science operations and use 460 hours of telescope time. So the 13 programs represent participation from 253 investigators from 18 different countries, 22 U.S. states, and 106 unique institutions, with an additional 449 science collaborators involved. And we are especially excited for all of this as there are UT astronomy faculty, staff, and graduate students on 5 of the 13 accepted proposals. Yeah, let's woo again. Woo! Woo! Big cheer. And on the screen are folks who were either the principal investigator or co-investigator, so that's like the big hot shot of the program. And so if you've been to AOTs before, you might recognize some of these folks as past speakers, and I hope you recognize the guy on the top right as he just gave a talk like 40 minutes ago. I hope you're not asleep. But yeah, round of applause for all of them. That's awesome.
All right, finally we have Astronomy Not in the News, where we talk about a recent discovery or result that has gained significant discussion within the astronomical community, but hasn't made the mainstream news, or of course the fake news. This month, a paper by Ling Zhu of the Max Planck Institute of Astronomy in Heidelberg, Germany. Ling and her collaborators modeled 300 nearby galaxies to determine how the stars in those galaxies, what the shape of the orbits within those galaxies are. They found that most stars within disk galaxies are in kind of an intermediate range. So in these plots, this is a plot from the paper, a little bit modified. So these are circular orbits. These are like long random orbits, and these are circular orbits that are going backwards. So disk galaxies have a lot of stuff in the middle. Spiral galaxies have more stuff in the middle, a lot of stuff up here, and then elliptical galaxies are mostly all random orbits and random elliptical orbits. So as expected in elliptical galaxies, most of the stars are in random elliptical orbits. Ling's work can provide a new way of classifying galaxies based on the motion of the stars in the galaxies rather than how the galaxies appear to us. By doing this, it may be possible to better understand the history of how galaxies have evolved and gained their current appearance. All right, that is all for Astronomy in the News for November.
Thank you very much.
Thank you all for coming.
Enjoy the rest of the show.